Hi guys! Did you miss me? I hope you did! Because I know I miss you too, and I miss making videos just for you. So if you think about yesterday, we were able to play my Mario Kart Wii game. Ngayon, we're gonna film some videos that pertain to our stats and probs. So now let's go to our stats and probs lesson. So far so good. We've already done the 4 items so far. The 4 sets, which are the areas underneath the normal curve, normal distribution word problems, sampling distribution of the sample means, and the central limit theorem. Ngayon, if we apply all the concepts that we learned so far, we could have been able to go to our concept called the hypothesis testing. So what is hypothesis testing? Hypothesis testing tells about whether we should reject the null hypothesis or whether we should accept the null hypothesis. So here are the concepts of hypothesis testing. I'll show you the concepts as we go along. First, we need to know exactly what is a null hypothesis. A null hypothesis is a claim, something that is intended to be true by the majority, although there are no subordinate claims that can disprove it. Because when we disprove a null hypothesis or disprove the original claim, that is what we call the alternative hypothesis. So when we say alternative hypothesis, this is a type of hypothesis that disproves the claim, while the null hypothesis is the initial claim, something that is meant to be true, although it's not meant to be, unless the alternative hypothesis wins. So ganito ang balak ng null hypothesis. The game of hypothesis testing is to test which among these two hypotheses is meant to be correct, the null hypothesis or the alternative hypothesis. And to do this, we can estimate it using level of significance. Level of significance tells us how confident we are in proclaiming the truth or denying that it can be false. That is what you call the level of significance. That is another concept. And then, of course, when we do hypothesis testing, it still implies the application of the normal distribution and the normal curve. And you will see why it makes sense, okay? And next of all, for hypothesis testing, when we do hypothesis testing, there are 2 types of tests that we're going to do. And what are those 2 types of tests? We call that the directional test and a non-directional test. In short, we call that a one-tailed test or a two-tailed test. So one time I'll get to the concepts in detail, okay? So now let's get to the problem. Starting off at number 1. Sammy and Addy need to drink their vitamins in a syrup every day in order that they can boost their immune systems. So here's the problem that's stated. So my cousins, Sammy and Addy, are drinking their vitamins each and every single day. They need it in order for them to become strong and healthy. Just like when I was a kid, I always gained vitamins from my mom, and my mom gives me vitamins in syrup. However, Lactus Sherwin, that's my uncle. Shout out to you, Lactus Sherwin, because I know you're watching my videos right now. I do not know how you're doing in the outside world, pero shout out to you po, uncle. So Lactus Sherwin claims that the average amount of vitamins that they need to take in every day is 14 ml. But, so yan, because that is the null hypothesis. So if you read to the problem, sabi dito, Lactus Sherwin claims that the average amount of vitamins they need to take is 14 ml. That is the null hypothesis. How can you say that it's the null hypothesis? Again, going to our definition, what is a null hypothesis? A null hypothesis is an hypothesis that is stated to become true, although it is not certain enough. That is what we call the claim, the initial claim. Okay? And then, di ba remember sabi dito, Lactus Sherwin claims that the average amount of vitamins is 14 ml. That is the claim. But when he consulted a pediatrician about this, okay, so when we say pediatrician, a pediatrician is what you call a doctor that is specialized for kids. So when he consulted a pediatrician, he surveyed a sample of 25 children and he got a sample mean of 16 ml. The standard deviation of the distribution is normally 5 ml. So, ganito kasi yun. Diba, remember sabihin ko that the null hypothesis can either be true or false, depending on the situation. Kasi nga, kung sa tingin mo dito, the null hypothesis is 14 ml. And that was said by Malacchio Sherwin. Pero, when he consulted a pediatrician, ang ginawa ni pediatrician, kinonsult niya kasi nga gusto ni Lactio Sherwin kung 14 ml ay sapat na yan. Pero, when a doctor sampled it, he sampled 25 children who took the medicine, and then they got a sample mean of 16 ml. Kasi nga, sometimes, the null hypothesis may not be true due to the sample. So, therefore, we sampled 25 children, and we got a sample mean of 16. And the standard deviation of the distribution is normally 5. And then, the question is, was the null hypothesis rejected or accepted? Kaya nga yun ang sabihin ko dito sa question na to. Because the goal of hypothesis testing is to test whether the null hypothesis were rejected or accepted. Use a one-tailed test and 5% level of significance for this problem. Diba sabi ko, ang level of significance, that tests the confidence level if we are confident enough to reject it or to accept it. And one-tailed test, because diba sabi ko dito, it is a one-tailed test, therefore, it is directional. But let's write down the given. Okay, so ito muna yung solution sheet na ginawa ko. So here's my solution sheet in hypothesis testing. So first, let's identify the given. Of course, when we do hypothesis testing, when we compute, of course, when we compute for the hypothesis testing, it still applies the application of the normal distribution. We still apply the Z formula. You know the Z formula, right? The Z formula is always this formula. Ganito kasi yun. Ang Z formula mo is always Z is equivalent to X minus the mu sigma divided by the square root of N. You know already that's the value of Z. Pero later, I will show you why this Z is also used in hypothesis testing. Okay? First, let's identify the given. So what is our X? Our X is the sample mean. So we know that the sample mean is 16. And then what is the mu? The mu is 14. Diba? And then standard deviation is 5. And then square root of 25. So as we simplify this, ganito kasi yung mangyayari. It goes like this. So 16 minus, so we identify the given, X is 16, mu is 14, standard deviation is 5, and we survey 25 children. So when we plug this in our formula, 16 minus 14, X minus the mu, and then 5 divided by the square root of 25. So 16 minus 14 is positive 2. And 5 divided by the square root of 25 is, square root of 25 is 5, and 5 divided by 5 is 1. And 2 divided by 1 is 2. So therefore, our z-score is 2. Pero wait, that is our z-score. Pero that pertains to here. If you look at our normal curve, yes, it still implies the application of the normal curve. Pero it's asking us if the null hypothesis were accepted or rejected. Before that, di ba remember sabi ko sa iyo, our standard deviation in the sampling distribution is 1. So we have 14 as the mean, so 14 ml, 13 ml, 12 ml, 11 ml, 15, 16, 17. Pero it says one-tailed test. So if we're referring to a one-tailed test, what does that mean? It can be tested on the left side of the distribution or the right side of the distribution. But which one? If you look at what the instruction says, it is tested on the right side. Bakit? Because look, it says they got a sample mean of 16 ml, which is higher than 14 ml. So we are using a one-tailed test for this problem. So we are going to test if 16 ml is much more sustainable. That's why we are using the right-tailed test. Because sometimes if you lack vitamins, you won't go strong. Or sometimes you just take the original exact amount. So we need more. Kaya nga that's why nga we need to use the right-tailed test. So ganito kasi yun. Now, diba remember sabi ko kanina, our 5% is what we call our level of significance. So what is a level of significance? A level of significance tells us the confidence level of rejecting or accepting the null hypothesis. And we know that it's 5%. So 5%, which one? We are using the right tail. So dito siya. So therefore, the rest of the distribution, we are using a 95% confidence level. Whereas on this part, we are using on our level of significance, which we call alpha, we are using the 5%. So now we need to locate 5% in the graph. Pero looking at my z-table, we know from here to here, that's 45%. So where on earth is that 45%? Looking at my z-table here, the 45% should be, yan, 44.95 and 45.05. So therefore, there's no such thing like that. And it's at the 1.6. 0, 1, 2, 3, 4. 4 to 5. So now we apply the linear interpolation to solve for the problem. So ganito kasi yun. So now we have this linear interpolation formula. So we need to know exactly what is the z-score. Kasi nga, we are not so sure exactly. Imagine if this area weren't shaded. We are not so sure where exactly is the rejection region. Kasi po, remember, they said, di ba remember kanina, I showed you how to compute for the z. And we got our z as 2. Pero, is the null hypothesis accepted or rejected? Ganito kasi yung criteria. In hypothesis testing, if your z value lands on the critical area where the rejection region is, that is when we negate the null hypothesis and reject it. However, when your z value lands on somewhere not within the rejection boundary, therefore, the null hypothesis is accepted. So yan. So if you look at this problem, we are not so sure where exactly the rejection region is. So what do we do now? Diba remember sabi ko sa'yo, we're using a 5% level of significance and a one-tailed test. So we're using the 95% here and 5% on the right-hand side of the distribution is negative, is the rejection. So to do this, we need to know exactly what z-score pertains to the rejection, which is the 5% on the east side, on the farther side of the north, or on the highest accumulation value. And that is 45.05% minus 44.95%. And this is what we did in linear interpolation. So this one here on the top side, we get 0.05. This one we get 0.01, just like that. 0.005. I meant 0.001, diba? Because that's 10, diba? 0.001, 0.01. Just like that, diba? So yun. This is 0.0010 and 0.01. Then on the right-hand side, this becomes 0.0005. On the right side, diba? And divide by x minus 1.64. And then ang ginawa ko dito, we divide the 0.001, divide by 0.001, and then we get this answer of 0.01. Tama? And now we apply the distributive property. We apply the cross multiplication. So 0.1 times x, 0.1x. 0.1 times 1.64 is 0.164 is equivalent to 0.005. Then we add 0.164 to both sides, and we get 0.1645. Then divide by sides by 0.1. We shift the decimal place to the right. So therefore, our z is 1.645. So therefore, our x value, so therefore, the area where the null hypothesis, where the rejection region starts to occur is at the 1.645. That is the z-score when we are going to start where the rejection area happens up to positive infinity. Now, do I remember you're asking me a while ago, what is the critical value and what is the z that we computed? Ganito kasi yun. Do I remember this z here that pertains to the area where we're going to have the probability chance of rejecting it is at what we call the critical value. That is the z critical value. Dito siya, di ba? Critical value. Pero, the computed z value we got is 2. Di ba remember, our z value is positive 2. And here, the positive 2 is here. And then, it lies somewhere in the rejection area. So, what do we do now? Do we accept the null hypothesis or do we reject the null hypothesis? So, as you can see, our computed z value lands in the rejection area. Since the rejection area is using 5% level of significance and it is a one-tailed test, and we know that the start of a rejection area on the positive side is when the z-score is becoming 1.645. So therefore, we should reject the null hypothesis. And that is the answer. So therefore, the null hypothesis was rejected. To show you my solution sheet, ganito kasi yun. So first, we need to state what is the null hypothesis. So what is the null hypothesis? The null hypothesis is mu is equivalent to 14 ml. That is the null hypothesis. When we say the null hypothesis, ibig sabihin, that is the initial claim. What is claimed to be true. The null hypothesis is 14 ml. And what is the alternative hypothesis? The alternative hypothesis is a fact that negates the null hypothesis. It states that the alternative hypothesis provides more evidence compared to the null hypothesis. At sabi dito, your alternative hypothesis is greater than 14 ml. So that's what we're gonna test. If our null is 14 ml such that if kids need 14 ml of vitamins in order for them to survive, or sabi ni pediatrician, we need more than that in order for the children to survive. So therefore, that's what we're gonna test. Okay? And then our level of significance is always written as A, alpha. And our alpha is 5%. Translated to decimal, and that's 0.5. 0.05. Our standard deviation is 5 ml. And now we compute for the samples. So for the sample, we take the square root of n. And square root of 25, di ba remember dito, nagpindot ako ng SQRT 25 and we got 5. Di ba? And then the sample standard deviation is the sigma divided by the standard deviation. So that's 5 divided by the square root of 25, which is 5 and which is 1. So your sample standard deviation is 1. And then the computed z value. When we say to compute the z value, how do you compute for the z value? Diba, remember, this is what we do normally, diba? Pero, in this situation, in Microsoft Excel, ang kailangan mo gagawin ay standardize. So, standardize this formula. We type there, standardize, 16, 14, and then our sample standard deviation, which is 5, 1, and then we get 2. Did we get that? Yes. We got a sample standard deviation, a computed z value of 2. Diba? And then critical level, it tells us where does the rejection region start. And it's at 1.644, rounded to 1.645. Ang ginawa ko dito, I did here normal standard inverse. Diba, remember we say normal standard inverse, it gives you a z value of a corresponding probability that starts from negative infinity up to the area where you want it to stop. Like for example, diba, remember you want 50%. So therefore, the z is 0. Diba, remember, let's say for example, tinype mo dito, norm standard inverse, we type there 0.5. If we type 0.5, we should get 0. Because that's the mu. Diba? Pero, since it's 95%, diba, remember, we are using the right tail test. We know from here to, if we use our z table, diba, this is supposed to be 45%. This is 50%. So 50 plus 45 equals 95%. And this is the 5% where the rejection region happens. Okay? So now we have 5%, which is the rejection region. And remember, it so happens that it implies the application of errors underneath the normal curve. Because if I remember, this shaded here is the rejection region. And we want to know what is the z-score of that rejection. So therefore, we type normal standard inverse, gives us a probability, gives us a z-score of a corresponding probability, and we type 95%. Pero, because remember, we're using 5% level of significance, so therefore, it's 1 minus 5%. 1 minus 0.05. And that's the same as 95%. Diba? And when we do that, we get this answer of 1.6458. 64485. Which is rounded to 1.645. And then the last thing you need to do is what you call the decision rule. When we say decision rule, ibig sabihin, this tells if the null hypothesis were rejected or accepted. Kasi nga, diba, remember dito, if your null hypothesis lies within the rejection region, therefore, if your computed z value lands on the rejection region, therefore, you're forced to reject the null hypothesis. Pero ang sabi ko dito, we rejected it. Pero paano ko ginawa yung formula na to? Ganito kasi yun. I use the if formula. Diba, remember sabi dito sa if formula, if, then logical test. What logical test you want to prove? The logical test is this. If M229, which is our computed z value, if your computed Z value is greater than, kaya nga sabi may greater than sign, di ba? Is greater than your, because we are using the right tail test. So we're using the right tail, so therefore greater than. If your Z value is greater than your critical value, the critical level, which is 1.645, di ba? Kasi nga, diba, remember, your computed Z value is here. And if your computed Z value lies within the rejection region or the rejection area, therefore, that is greater than. Diba? So we know this is the greater than area, diba? And then, so therefore, if your computed Z value, which is 2, is greater than or within the boundary of 1.645, that is, it's inside the rejection area, which is here, we are forced to reject it. So we type there, logical test, if 2 is greater than 1.645, the Z score, and then we type here, value of true. If it's correct, we reject. If it's greater than, we reject the null hypothesis. If false, do not reject or accept. And we got reject because of this value. So therefore, we reject the null hypothesis. So therefore, what is the conclusion? The conclusion is the null hypothesis was rejected, not accepted.